Video recording. Okay, so what we're going to do today is do a little review of our test, which is on Thursday. Our test will cover chapters 7 through 12, so I'll go over things that you should know for the test. And then we'll have a quiz. Quiz will be on chapters 11 and 12. That'll be two. Seems like people are still coming in. All right. So let me just start to give you some information about the quiz. And I'm going to show you an Excel spreadsheet that's posted that might be helpful in your some calculations that you may be doing during the test. Just a second here. All right, so hopefully you can hear me okay. I'm not going to share the screen at the moment. I'm just going to go over some of the information on the test. So what types of things do you need to know for this test? Number one, you need to know some of the measures of center and variability that we talked about, such as the mean, the median, and the mode. Okay. Outliers, you have to know in general what an outlier is, and how an outlier might change the mean, median, and mode. For example, an outlier will definitely change the mean, but it will not change the median. The median, remember, if you have a sorted data set from smallest to largest, median is the number in the middle. People are coming in very late today. So the median is in the middle, and therefore outliers that are unusually small or unusually large are not going to affect the median. But the mean, which is the sum of all the values divided by the number of values, will be affected by any unusually small or large values. So the mean is affected by outliers. The median is not affected by outliers. Okay, you should know that. You should know what a stem plot is. So the stem plot is different than other types of plots because it actually has the actual numbers that you can see. So if a stem plot is displayed, you can actually take the numbers right off the stem plot and calculate things like the mean and the standard deviation and things like that. Okay. All right, so the stem plot is different in that respect. Okay. Now, histogram is also for quantitative data, just like the stem plot is, but the histogram, typically you'll have ranges of values along the x-axis, and then the number in each of those ranges or classes. So you won't see the individual values necessarily, but a stem plot you will. You should be taking notes right now. All right, don't just sit there and listen to me and then forget exactly what I said, because I'm giving you hints for this test. All right, you should be taking notes. Now, regarding the outliers, if you have a data set that is skewed to the left, which means the data set is tailing towards the left, most of the data is on the right, it's tailing towards the left, it means you have unusually small values in the data set, which in a sense is making the mean smaller than the median. Okay, so skewed to the left means the data is tailing off to the left. You have unusually small values, and the mean is going to be less than the median. If the data set is skewed to the right, it means we have unusually large values. Most of the data is lower, but there's unusually large values, and that makes the mean bigger than the median. Now, if the data set is symmetric, like bell-shaped, then the mean and median are approximately equal to each other. So that is very important to know. Box plot is a graphical display of what's called the 5-number summary. What is a 5-number summary? It's the median. It's the lowest value, median. All right. The first quartile, the third quartile, and the maximum value. Let me say it one more time. It's the lowest value, the lower quartile, the median, the upper quartile, and the largest value. It does not include the mean. The mean is not part of the 5-number summary. And a box plot is just a graphical display of the 5-number summary. There's no mean there. The median's there, but not the mean. What else can you calculate from a 5-number summary? You can calculate the range, which is the largest value minus the smallest value. And you can calculate the interquartile range, which is the upper quartile minus the lower quartile. You must know these things. I'm telling you, you must know these things. I'm telling you. Take notes, all I'm saying. Write these things down so that you study the right things. Don't just listen what I'm saying or play on your on your phone while I'm talking. Don't do any of that. All right. You should be listening right now. All right. So those things are important. And the box plot, there is in the sections that deals with the box plot, there is a calculation determining if a particular value is an outlier. All right. You should review that because an outlier is determined by what? Well, you calculate the interquartile range first, the upper quartile minus the lower quartile. You multiply that interquartile range by 1.5. And then with that 1.5 times the interquartile range, that number, you're going to, number one, add it to the upper quartile. And you're going to see if there's any numbers in the data set that are bigger than that. So the upper quartile plus 1.5 times the interquartile range. If you find any numbers in the data set that are larger than that, those numbers are an outlier. Those are the large outliers. In a similar way, what we're going to do is, once we've calculated the 1.5 times the interquartile range, we're going to subtract it from the lower quartile, and we get a number. And any numbers in the data set that are smaller than that are also outliers. So they are the small outliers. So that's how you calculate it. It's all in your book. It's all in the notes. So make sure you know how to do that, because there might be questions about outliers and determining whether a particular value is an outlier. Now, in the book, the 5-number summary sometimes is displayed as a rectangle, and inside the rectangle are the 5-number summaries. So make sure when you do your review, you're familiar with that box that you may see, that box which has the 5-number summary inside, and you know which of those numbers is the median, which is the lower number, the smallest number, the highest number, the lower quartile, the upper quartile. You know where they are inside that box. All right. So look at questions just like that. All right. I give you a 5-number summary. You should be able to calculate the range, determine outliers, determine also, with the 5-number summary, of course, you can create a box plot out of that, but you should be able to know that the 5-number summary creates quartiles. That is, between the smallest number and the lower quartile is 25% of the data. Between the lower quartile and the median is 25%. Between the median and the upper quartile is 25%. And between the upper quartile and the largest number is 25%. Must know that. All right. I'm telling you, write this stuff down. You write all this down and study it and know how to interpret it and all. You'll do very well in this test. If you don't, and you walk in cold, you won't do very well in this test. You'll do very poorly in this test. Giving you all these hints. All right. Definition of a percentile. I'll give you a situation where it asks you about a percentile and the interpretation of it. You must know what a percentile means. What does it mean? All right. It's in your book. You went over it in class. Let's see what else is here. Suppose I give you the mean and the standard deviation. All right. Suppose we have one of those bell-shaped normal curves. Okay. And I might ask you, for example, how much of the data is between two plus or minus 1 standard deviation, plus or minus 2 standard deviations, like that. That's the empirical rule. That's the 68%, the 95%, the 99.7%. Remember that? And you should also be able to convert if you're given the mean and standard deviation, you should be able to convert a score, a raw score, into a standard score, standardized score. All right? That's important also. You know how to do that. You should be familiar with the types of graphs that are for categorical data. All right? Categorical data, there's a whole section in the book about that, the different types of graphs for that. You should be familiar with the types of graphs or pictures that are for quantitative or measurement data. It's the same thing. Quantitative measurement means the same thing. All right. You should know something about, this is important, the variance or standard deviation, but the variance, how it's calculated. Now, how is the variance calculated? Now, you don't have to do the calculation itself, but what you need to do in terms of the what a variance is, you have to know how it's calculated. So first of all, we have to calculate the mean of the data set. Then for each data value in the data set, we subtract the mean from that each data value, right? And then we square those differences. So the data value minus the mean squared for each of the data values. And then we divide that by the number of values minus 1. And that's called a variance. That's called a variance. Now, when we square numbers, can we ever have negative numbers as a result? Can anybody say that for sure? If we square numbers, can we get a negative number out of that? Are you there? Anybody there listening?
I would think no.
That's right. Because when you square a negative number, you get a positive number. You always get positive numbers when you square. So the variance, this is what you have to be very clear about. The variance involves squaring numbers, isn't it? When I tell you, you take your mean and subtract it from a number and then square it, that result can never be negative. And when we add them all up, all these squared differences between each value and the mean, and we add all those numbers, the lowest value it can be is 0. It can never be negative. If you add up a bunch of positive numbers, it can be 0 if all the numbers are 0, but certainly it's going to be most likely positive. So the variance is always positive or 0. It can never be negative. That makes sense? And the standard deviation is just a square root of the variance. So when you take the square root of a positive number, you're going to get a positive number also. So the variance and standard deviation are never negative. All right? Also, you should understand that when the variance is calculated, there's going to be units of measurement. You know, if all the values in a data set are heights and they're measured in inches, then when we square the difference between each value and the mean, we're squaring those units of measurement. In other words, we're going to end up with squared inches. Well, the squared inches is not a measure of height. So that's why we have to take the square root to get the standard deviation. Because when we take the square root, we're taking the square root of those squared inches, and we get back to the original units of measurement, which are inches. So the variance is not in the original units of measurement. They're in the squared units of measurement. Is that clear? Only the standard deviation is in the original units of measurement. All right. So these are things you need to know. Write them down. All right. And I'll be able to tell how people do in this test based on whether you're paying attention now or not, because this is going to be success or failure for this test based on what you're doing right this second. All right. Correlation. You should know the interpretation of correlation. For example, positive correlation means As one variable's value goes up, the other variable's value goes up. As one variable's value goes down, the other variable values goes down. In other words, the values go in the same direction. That's called positive correlation. Does that make sense? Positive correlation. Negative correlation means they move in opposite directions. As one value goes up, the other goes down. As one value goes down, the other one goes up. All right, that's the interpretation of correlation. All right, everybody clear on that? That's in terms of the direction of the correlation. If it's negative, the values typically move in opposite directions. If it's positive, they move in the same direction. You also need to know about regression, right? The regression line. What's regression? Well, we're looking at two quantitative variables, an x variable and a y variable. And we have a correlation between them, right? So we have a scatter plot, which is a bunch of xy points. And then we have a line that is the best fitting line that goes through those points. That line will have a slope and y-intercept, just like what you learned in high school. And the correlation, if the correlation between the x and y values is very strong, which means it's either very close to +1 or close to -1, then those points will be very close to that line. It sort of hug the line. But if it's weaker, if it's not as close to +1 or -1, then those points will be more scattered, more away from the line. So here's the deal. If the correlation is high, pretty high, and we found the line of best fit, that line of best fit is a very good line for making predictions. That is, if we know an x, we can predict what y is. If the correlation is close to 0, it's small, then that line doesn't do a very good job of making predictions. It's not very good. We might as well not even use it. Get the idea? So correlation is important to know, because if it's close to 0, then even if we find the line of best fit, it's not going to really work very well. So the correlations need to be, quite a bit higher than 0, or quite a bit lower than 0, depending on whether we have a positively sloped line or a negatively sloped line, for it to be actually a useful line. All right. Now, how do we make the prediction? Well, number one, we want to, if we have the equation, we take we'll be given an x, a hypothetical x value, a value of x that's not in the data set. And we then replace the x in the equation with that value, multiply it by the slope, and add the y-intercept. And then we're done. We get our predicted y. All right. And I'll show you an example in a minute about that on the Excel spreadsheet that I'll be showing you. All right. Now, what is the interpretation of the slope of the regression line? Now, you learned this in high school, but I'm going to mention it again. For example, if the slope is +3, what does that mean? That means for every x that goes up by 1, the y increases by 3. That's what it means. Remember, rise over run? So rise is in the numerator, run is in the denominator. That's what slope is. So think of 3 as the slope as 3 divided by 1. That is, the rise is 3 and the run is 1. So for every increase of x of 1, the y increases by 3. That's the proper interpretation of slope. If the slope is -3, that means for every increase of x as 1, y decreases by 3. All right? So you should know that interpretation of slope, because it tells you exactly what the predicted values are going to be. All right? Let's see. Now, also understand that the y-intercept may not really make any sense in terms of interpretation. Now, what is the y-intercept? It's the value of y when x is 0. In other words, it's where the line intersects the y-axis. Now, it may not make any sense because x is equal to 0 may not make any sense. All right? X may be numbers that are always above 0. And so when you say x is 0, it's not something that can be interpreted. But it's there because it makes the equation of the line work. All right? So you still use it even though there's not really a good interpretation of the y-intercept. And also just remember that if the correlation is close to 0, it's a small number, close to 0, then predictions are not very useful, not very accurate. Now, on the test, there could be box plots. We could even compare two groups of people or different situations with box plots. In other words, the measurements are the same, but they could be different situations. All right. And we can compare with one box plot, the lower quartile, and maybe we're comparing it to what? Maybe the median of the other one, things like that. You should be able to interpret or compare box plots by just looking. All right. So that's the type of thing that you should be familiar with. These are called comparative box plots. You're just looking at two of them and just making comparisons. And just means that you're able to read a box plot and know where the lower quartile is and the median is and things like that. Also, if I give you a histogram, you should be able to find things like the median and the mode, all right, from the histogram. Now, the histogram, the y-axis should be in, not in the frequencies. They should be in the relative frequencies or percents, all right? And then you can make your judgment about what? About where the median is. Now, how do you do that? Well, you simply, the median is the 50th percentile. So what you do is you start from the left and add up the percents until you get to a rectangle in the histogram that would contain, you might say contain, the 50th percentile, and then you say the 50th percentile is that number. So again, a histogram is just these rectangles that are adjacent to each other with the quantitative variable running along the x-axis. And then running along the y-axis could be your relative frequency or percents. And to find things like the median, you would just start from the left and add your percents until you get to the rectangle that would contain that percent, and that would be your median. In the same way, the mode would be the tallest rectangle, right? Most frequent one is the tallest one. Okay. And then how do you find things like the lower quartile and the upper quartile? Well, if you know where the median is, the lower quartile is the 25th percentile. So again, you start from the left and you find the rectangle that would contain the 25th percentile. That's 25% of the data that's less than that. And how about the upper quartile? Well, you start from the left and add percents until you get to the rectangle that would contain the 75th percentile. And that's it. Now, also remember that when you calculate the correlation, you're looking at two quantitative variables and comparing them, and you calculate the correlation. Correlation does not imply causation. It does not, you cannot say that one variable causes the other. Unless what? Unless this data came from a randomized experiment. With a randomized experiment, you're randomly assigning people to treatments, and therefore the groups are going to be approximately the same, with the only difference being the treatment. That's different. So you can change the treatments and see if there's a change in the response variable. So correlation will not work for observational studies. in terms of determining cause and effect, one variable causing the other, but it will work for a randomized experiment. You can say correlation leads to cause and effect, only for randomized experiments. Okay. Now, one of the things that you'll be asked to do in this test is asked to find the mean and the standard deviation. Now, your calculator, if you have the TI-30X calculator, if that ran, you should be able to figure out how to enter data into it and then determine the mean and standard deviation. It's part of the features of it. You can always look it up. You can Google it. If you don't have that calculator and you don't have data on the features on it, then you'll use Microsoft Excel. All of you can use Microsoft Excel if you want to find the mean and standard deviation. I'll show you with Microsoft Excel how it works. But there will be a problem where you will have data set and then you'll be asked to find the mean and standard deviation. Just be careful. When I underline information in the problem, I'm doing it on purpose so that you pay attention to it. All right. So please don't go so quickly that you miss why I'm underlining things. All right. I'm underlining it so you pay attention to it. All right. So, you'll be asked to find the mean and standard deviation, the slope and intercept of the line of the regression line. I will also give you one of these contingency tables, one of these tables where we have categorical data, where we're comparing two categories. Remember, we have the count of each of the people in the survey that would be meeting the criteria of both categories. All right, you've seen this where we calculated what? The risk, we talked about risk, we talked about odds, right? So relative risk, percentages, odds ratios, things like that. Remember that? That was chapter 12. So we went over examples of that. And that's important to know how to, and I think I have a PDF that I posted that shows you an example of how to do that. Please review this before the test. Don't try to figure this stuff out coming into the test. All right, I'm not going to study for the test, and I'm going to just keep the stuff near me, and if I see the problem, I'm going to read it and try to figure it out. No. That's a recipe for disaster on the test. You're not going to do it well on the test if you do that. Know how to do things ahead of time. In other words, with pencil and paper, go through the examples I gave you and figure out how to do it before you take the test, not during the test. All right? That's a very bad way of studying for the test is to just let it go until the test itself. So one of those tables will be given. And you should know things about like the total number of people in the survey. You should be able to find it from the table. Should be able to calculate, as I said before, relative risk. And there's also a calculation that's similar to that called increased risk. Remember, you take your relative risk, subtract 1 and multiply by 100. That's the increased risk. Make sure you know how to do that. And you should also know how to calculate odds for each of the explanatory variable categories, and then to calculate an odds ratio. And also with the odds ratio, by the way, you're going to end up with something like, the odds of one category being 2 times higher than the odds of another category. All right. That's what an odds ratio gives you. And you should be able to also convert that to a percentage increase or a percentage change. How do you do that? You take your odds ratio and subtract 1 and multiply by 100. Just like you did with the relative risk, you could do that same thing with the odds ratio. Subtract 1 and multiply by 100, and you could say something like there's a 30% chance that one group has higher odds than the other group. All right, 30%, not 30% chance. The odds of one group is 30% higher than the odds for the other group. So that would be another way of interpreting the odds ratio. All right. That's pretty much what I'm going to what I wanted to go over with you as far as the test. And now I want to, unless you have some questions, I want to actually share with you the, all right, somebody has a question in the chat. If the correlation is positive, does it mean the slope is positive? Absolutely always. That's what correlation means. Upward slope. So if correlation is negative, it means the slope is negative. Okay. So yes, slope and the correlation have similar interpretations. So that's the answer to that question. John, is that good? I think you had asked a question. All right. And then zero, correlation close to zero means there's hardly any relationship between the two, and then you would have a horizontal line as the regression line. All right. Horizontal line means slope of zero. So correlation close to zero and a horizontal line also have similar interpretations. Also know that if you have a nonlinear type relationship, like U-shaped or something, nonlinear, that correlation doesn't make sense for that, because correlation measures the linear relationship between two variables. So if there's a strong nonlinear relationship, the correlation is useless. It's going to be zero. So it's going to be useless. It's not even relevant for a nonlinear relationship. All right. Does that help, John? Yes? All right. So I'll share the screen with you, and let's go to this one here. I'm going to enable editing here.
Professor,
Uh-huh. Yes.
I'm gonna turn my screen off really quick. I have to use the bathroom.
Okay. You can do that.
All right.
Make sure you're back here by 10 minutes too. All right.
Yeah, of course. I'll be right back. I'll be fast. Okay.
That's all right. That's all right. All right. So there's a couple different pieces to this spreadsheet. On the left here, I'm just giving you a general X and a Y. Just making some numbers up. So your X's are your what are called the independent variable. Sometimes it's if it's an experiment, it's the explanatory variable. The Y is the dependent variable. And again, if it's an experiment, it's the response variable. And then we can calculate things like the correlation. And how do we do that? Well, I'm going to click this cell right here next to the word correlation. And for formulas, for functions, they're called functions in Excel. If you want to calculate using a function, you use an equal sign first, and then you type in your function. Now the function for correlation is CORREL, standing for correlation. And then you open up a set of parentheses, and then, so let me just show you. I'm going to do something in a different cell here. I'll just show you what so I'm going to type in equal sign and then CORREL. All right, and I'm going to double click on that, and notice what it says here. It has array 1, comma, array 2. An array is just a list of numbers. All right, so I would recommend when you calculate anything that deals with regression or correlation is that the first array would be your Y value. So you just highlight the first Y value and just scroll down, holding the left key down on your mouse. Hold it all the way down to the last one. Notice it says D10 colon D5 colon D10, which is those numbers there. And then you put a comma in. So you type in the comma. And then you put your X's in. So you got the X column and then scroll down, hold the key, the left key down, and then get to the last one. Notice it goes C5 to C10, and then you close the parentheses. All right, and then you, of course, hit enter. And so that's how we came up with the negative 0.17342. Notice it's a negative correlation. I'm going to delete that. So go down to here. Notice this is a negative correlation. It's not very strong. It's closer to the 0 than it is to -1. So this is a weak negative correlation. But it means that the line, the regression line that represents the point, these points here, if you graph the points, would be slightly negative, would be negatively sloped. All right, would be negatively sloped, but the points would be scattered around these points. It wouldn't be this line is not going to do a great job of predicting a y from an x. Here's your slope. Notice that the slope has the same sign as the correlation. It will always match. The slope is -2. It's -0.82857. Notice to find the slope, I'm going to use the function slope. I'm going to say equal slope. And then the first, again, I'll go back up here just to show you how we do it. So it's equal slope. And I'm going to double click on slope. And notice it says known y's. That's our y values, which is the y's here. That's our dependent variable. And then comma known x's. So I would just get in the habit doing the y's first and then the x's, those parentheses, and then you get your number. All right. So that's how I got the number below. This number here. And then the y-intercept, you're going to use the function intercept. So it's going to be equal intercept. Again, the y's first, comma, the x's. And then you'll get 12.4 as your y-intercept. So this is the regression equation. I just typed it in. This is not an actual equation here. Notice I just typed in this text here. So the equation is going to be 12.4 minus your slope times x. Now, why do I have minus here? Because it's a negative slope. If it was a positive slope, I'd have a plus there. Okay? So it's the y-intercept plus the slope times the x-intercept, but it's negative because the slope is negative. All right. Hopefully that's clear. And then if I wanted to make a prediction, I would just I'll give you an x. Let's say I give you an x 1.5 here. That's not in the data set. All right, so I'm going to type in 1.5, and I want to predict what y is. All right, now how do I do that? Well, I can go just below there. So if my x, I'll just type in x here. If x is 1.5, what is y? Well, you replace the x in the equation with 1.5. So this is how I would do it. I would say equal. And the equation says, take your x and multiply it by the slope. So I'm going to take my x, which is 1.5, and then I'm going to put the asterisk next to it. That's for multiplication in Excel. And I'm going to multiply it by the slope. Well, where's the slope? It's this number here. So let's click the number. So that's my x times the slope, and then I have to add the y-intercept, and the y-intercept's here. So I put plus and y-intercept. Hit enter. And there's my predicted y. All right, so that's how you do it in Excel. You don't even need your calculator if you're doing all this work in Excel. So you take your x, whatever's given, you multiply it by the slope. So here's the equation up here, C12, which is where the x is, times F7, which is the slope, plus the y-intercept, which is an F8. And then hit enter and you get your answer. All right, and that's how I found the predicted value of y. This is how you can do this in Excel. All right, so if you want, you can use this spreadsheet that's here as a template. And if you're given a problem, make sure that you enter all the x's in and the y's in the same order. It has to be the same order because remember, each of the x's and y's are paired. They're connected with each other. So you don't want them in different orders. You want the x's and y's in the same order. And then, so, if there is more than 6 x's and 6 y's, then you need to, of course, if you know how to cut and paste, you can cut this and paste it down here somewhere. And then just continue with your x's and y's until you get them all in. And then Then you'll be able to, again, calculate your correlation, the slope and y-intercept, and then you can make a prediction in Excel. All right, so this is how you do it in general. It's pretty easy. As long as you practice this before you take your test. There are examples in the book, by the way, where they'll give you X's and Y's, and you can simply use your spreadsheet here and calculate. Now, remember, if the number of X's and number of Y's change, you have to change this formula in here, right? The Y's are going to let's go here. The Y's are going to be starting here and then maybe going all the way down to 21 or 22, wherever you stop. Make sure that you include all of those Y's in the formula. Don't use the same formula as before, right? The arrays are going to be different. All right, we're going to use a different Y's and different X's. So please change this in here so that these, you could start at D5 for the Y's and C5 for the X's, but make sure you end where the actual list ends. So you're going to have to redo it. All right, is that clear? I think some people think what I've done here is set in stone. It's not set in stone. These lists here are going to change based on what the numbers are and how long the list is. Please be careful with that. Now here's an example over here. This example actually comes from the book, I think. I think it's in the chapter that does the regression. There's this example where we have how many cities we have. 1, 2, 3. We have 8 cities in the United States. I think I might have shown you this as an example before. And we have average temperatures in June and December. The June temperatures are the X's. They would run along the x-axis, and the Y's are the December temperatures along the y-axis. So the X's are going to be your independent variable, and the Y's are going to be your dependent variable. And what you're trying to do is you're going to say, what if I'm given a temperature in June, can I predict the temperature in December? Well, we're with these 8 cities, of course, you're given that information, but what if you had another city like Philadelphia or Newark or New York? Well, no, we have New York, but Newark or Miami, whatever, that's not in the list here, and you have the June temperature, can you predict its December temperature? So things that you could do here are, first of all, the correlation. Here's the correlation here, using the same formula, but this time we're starting at we're using the, well, in this case, we're using the X's first, but again, I would recommend using the Y's first. It doesn't really matter with correlation, get the same answer. So you use the ends, starting at N6 and going to where? N13. Notice that when I click this, you look on the left here, you see the highlighted 6 and the highlighted N. It tells you you're in N6. All right, so Excel does a nice job with that. And then it goes from N6 all the way down to N13. So make sure when you do the correlations, you run from 6 to 13, both for the N and O columns. All right. You get a strong positive correlation here, not a negative correlation, positive correlation. Notice the slope is positive, it should match. The slope, again, now you have to be careful. You have to put the Y's in first. So it's O6 through O13, and then the X's in next. If you happen to switch it, you're going to get a different equation. All right, so be very careful here. The slope and the y-intercept require you to put the y's in first, and comma, then the x's. All right, make a note about that. If you get it backwards, you're going to get the wrong equation, and I'll assure you that if I ask for the equation in a multiple choice test, I will give you the equation where you make that mistake also. So if you make that mistake, you will put the wrong answer down because you'll see it. So I'm telling you, be careful. Put the y's in first and then the x's when you're doing it in Excel. Same thing with the y-intercept. The y's go in first and then the x's. All right. So this is your equation. I just typed it in, like I said before. This is just a text here of typing in the equation, just so that I could see it. And then if I wanted to make a prediction, like Philadelphia, I could type in Philadelphia here. Philadelphia. Let's make up the Philadelphia's June temperature. Let's say in June, it was averaging 75 degrees. Okay. We want to predict the Y temperature. How would we do that? It's not in this list, Philadelphia, so we have to make a prediction. Well, we want to take that X and multiply it by the slope. So we're going to say, we're going to point to the X value, and then we're going to multiply with the asterisk times the slope, and then we want to add the y-intercept. Enter, and there's your predicted temperature in December. It's predicted because it's not given. Okay. So there's an example of prediction. Now I didn't, when I posted this, I didn't put this in here, but you can practice it. Put in your own city, put in your own June temperature, and just play around with this. All right. I don't want you just to look at it and say, okay, I know how to do this. Play with this. You won't destroy the spreadsheet as long as you don't change anything, you know, anything that I have in here. You can play with other things. You can add a city, you could put in a June temperature and then do your predicted December temperature and see if it makes sense, your answer. Okay. So you're not going to hurt anything by playing around.
Professor, can I ask you a quick question? I'm so sorry.
Yeah, the quiz is about to start, so
I know
me the
the
question.
quiz is on the quiz is on chapter 11 and 12.
11 and 12, that's what I had said.
All right.
Now, let me just tell you one more thing, so because this quiz is starting right now. You can also calculate the mean using the function average. The mean of either the X or the Y here. So I did it for both X and Y. All right, so the average of N6 through N13, that would be the average of the June temperatures. I do the same thing for the December temperatures. And so use the word average, the function average, equal average. And for the standard deviation, you're going to use STDEV dot S. That's a sample standard deviation. Please, we're only going to be using that in this course. Please use that one, STDEV dot S. And then you use, and then you just calculate it by, again, scrolling down for your array. And I did it for both of these things. Okay. So this is posted. You can download it into your computer and play with it. All right. Play around and come up with different, you know, look at examples in the book and see if you can do it in Excel. All right. That's it for the review. Any questions? Oops. Did not want. All right, stop sharing that. Okay. So any questions? All right. So your quiz will begin. All right. Come on, apartment. All right. This is not good to, you have to have cameras for your tests, folks, but I will give you the excuse here. But the third test and the final, I will not have no excuses for not having cameras. You have to, we're midway through the semester. You know you need cameras for testing. You have to get these things fixed. All right. Very important. I have to see you while you're taking your test. You shouldn't be taking a test on your phone or an iPad. You should be taking it on a computer somewhere where there's a computer. All right. All right. So anyway, start your quiz. You should have enough time, but if you need a little extra time at the end, let me know and I'll add a couple minutes to your quiz. All right. Let me know with a thumbs up that you see the quiz. Everybody see it? You may begin.